But the mystery grows deeper. Chemical studies reveal that 3I Atlas holds water ice and organic molecules untouched for over 7 billion years, predating our own planet by a wide margin. This is not a stray rock from our neighborhood. It is a relic from an ancient galaxy, preserved since before the sun was born. If 3I Atlas is more than a frozen wanderer, the stakes are colossal. Overlooking the clues could mean losing a once-in-a-lifetime opportunity to answer the oldest questions. Are we alone? Do we understand our place in the cosmos? To dismiss this event might cost us not only knowledge, but also the chance to respond to a message we do not yet recognize. Yet the arguments are just beginning. Some insist it is a rare but natural comet, while others are unsettled by the object's perfect timing and suspicious trajectory. Its arrival is no accident. The sequence is so precise, the alignment so uncanny, that a rising number of experts are considering the impossible. What if this is not a fluke, but a crafted signal? Evidence of alien intent or technology? Imagine something older than the Earth itself slicing through our solar system, not drifting by chance, but moving as if guided. Astronomers have just detected an interstellar object named 3I Atlas, and its behavior is unlike anything they have seen before. Instead of a wild random path, its course threads with eerie precision past Venus, Mars, and Jupiter. An alignment so exact that scientists estimate the odds at just 1 in 20,000. For nearly all of human history, no one had ever witnessed an object from beyond our own sun. Curiosity is at a breaking point, and divisions are splitting the scientific community. What exactly is 3I Atlas? To answer that, we must trace how it was found and what sets it apart from every other interstellar visitor in memory. The discovery of 3-eyed Atlas began with a faint, unlikely blip in a crowded sky. Only by retracing those first moments can we understand why its arrival sent shockwaves through the world of astronomy. Picture the Milky Way as an endless ocean, crowded with drifting icebergs and lost fragments. Astronomers long suspected untold numbers of cosmic wanderers journeyed between the stars, but for centuries, not a single one crossed our view. The idea that a true interstellar visitor might streak through our solar system was the stuff of legend. So unlikely, most believed it would happen only once in several lifetimes, if it happened at all. Less than 2 years later, the impossible happened again. In the summer of 2019, astronomers detected Borisov, a blazing, volatile comet, tearing through the solar system. This time, there was no doubt. Borisov's chemistry was nothing like anything born in our own star's nursery. Here was a true alien visitor, forged in the icy outer reaches of another sun, now shedding gas and dust as it raced past. Then, in the autumn of 2017, everything changed. On a mountaintop in Hawaii, a telescope caught sight of something impossible, a slender, tumbling object moving faster than any known comet or asteroid. Scientists named it Oumuamua, Hawaiian for a messenger from afar arriving first. Oumuamua defied every expectation. It showed no cometary tail, accelerated in ways no simple rock could, and left even seasoned experts mystified. Was it a shard from a shattered world, or something stranger still? The Oumuamua case is an excellent example of how a single discovery can challenge decades of astronomical assumptions. When it was detected, astronomers scrambled to study its speed, trajectory, and reflectivity, only to conclude that it did not fit any known category. Some even proposed that it might be a fragment of an alien probe, although most favored natural explanations. Regardless, the object's rapid departure from the solar system left more questions than answers, fueling new interest in the search for interstellar visitors. For the scientific community, the appearance of 2 interstellar objects in as many years was staggering. For generations, such events were thought to be once-in-a-century flukes, not back-to-back surprises. Was our technology suddenly revealing a hidden cosmic traffic? Or was something in the galaxy shifting? To put this in context, consider how rare it is for even ordinary comets to pass close to Earth. Before Oumuamua and Borisov, astronomers had cataloged thousands of comets, all from within our solar system. The chances of spotting an object from another star system were thought to be so slim that some models predicted only one such event every few thousand years. Yet after Borisov, the heavens fell silent. Despite better surveys and newer telescopes, not a single new interstellar guest arrived for nearly 6 years. Doubt crept in. Had Oumuamua and Borisov just been lucky glimpses, oddities in an otherwise empty sky? Then, just as the search seemed hopeless, another visitor emerged, shattering every assumption. 3I Atlas appeared, and it was nothing like its predecessors. Larger, far older, and wrapped in impossibilities, it challenges everything we believe about cosmic randomness and the limits of nature. 3I Atlas is not just another interstellar rock. Its origins, age, and almost impossibly precise trajectory force us to question whether we have encountered a natural relic or something deliberately sent. Atlas refuses to fit any pattern we have seen before. Is this merely the wild unpredictability of nature, or could it be something more, something shaped by intent? Let's untangle the mysteries, thread by thread. Atlas is not just tumbling through the solar system. It moves with retrograde motion, against the normal flow of planets. Yet its trajectory stays astonishingly precise, almost exactly within the planetary plane, drifting by less than 5 degrees from the ecliptic. That kind of alignment hints at planning, not the aimless path of a cosmic drifter. The oddities multiply. Atlas's path brushes past Venus, then Mars, then Jupiter, in that exact order. Each flyby happens within days of the predicted window, as if timed by an unseen hand. The odds of such a sequence occurring by sheer luck are vanishingly small, akin to winning the galactic lottery on the first ticket. To understand how strange this is, imagine you are tossing a frisbee into a crowded room. The odds of it passing precisely between 3 chairs, one after another, without touching anything, are astronomically low, unless someone is guiding it. Similarly, Atlas's path through the solar system suggests either a cosmic fluke of monumental proportions or a trajectory influenced by some guiding force. Let's compare this to historical astronomical events. When Halley's comet passes Earth every 76 years, its timing and trajectory are predictable because it is bound by solar gravity. But no interstellar object has ever followed such a choreographed route through multiple planetary neighborhoods. Atlas's course is not just rare, it is unique in the annals of astronomy. Atlas's physical features are just as confounding. Its coma and tail appear far from the sun, at distances where no comet should be active. Even more unsettling, the coma sometimes points toward the sun, flouting the basic rules of comet physics. The tail shifts in ways that make no sense, as if following instructions we do not understand. Spectroscopic scans unlock another layer of strangeness. Atlas's surface holds untouched water ice, complex organic compounds, and ancient silicates, materials that have changed little since the galaxy's birth, over 7 billion years ago. Somehow, it has avoided both the roasting of nearby stars and the violence of cosmic collisions. It is a relic, a message in a bottle from the dawn of everything we know. For comparison, most objects in our solar system have been battered by billions of years of impacts, erosion, and radiation. The preservation of Atlas's chemistry hints at a journey through the cold, dark spaces between stars, untouched by the chaos that shapes most planetary bodies. This makes Atlas a scientific time capsule, offering a rare look at primordial material from the galaxy's youth. To put this in perspective, standard comet physics predicts that a comet's tail always points away from the sun, driven by solar wind. The reversal of Atlas's tail direction at various points has led some researchers to compare it to controlled propulsion, as if the object were adjusting its orientation. While such a claim is extraordinary, it recalls the historical discovery of comet tails by astronomer Giovanni Schiaparelli in the 19th century, who established the solar wind theory, now apparently defied by Atlas. Size amplifies the mystery. Atlas measures somewhere between 4 and 11 kilometers across. That is far larger than any known interstellar visitor and far older. Its intact chemistry and bulk make it a scientific prize we may never see again. The pressure mounts. If we are to learn from Atlas, this may be our only chance. To illustrate, Oumuamua was estimated to be only a few hundred meters long, while Borisov was about a kilometer across. Atlas dwarfs them both, making it not only rarer, but also more valuable to science. Think of it as finding not just a message in a bottle, but an entire library adrift in the cosmic ocean. Atlas's origin deepens the puzzle. It comes from the direction of Sagittarius, the galactic core, a stellar metropolis so dense and chaotic that finding a faint object is nearly impossible. That it appeared from the most crowded, obscured region in the sky feels less like chance, more like a cosmic riddle. Did Atlas simply wander into view, or was it meant to? For a historical parallel, consider the Tunguska event of 1908, when a mysterious object exploded over Siberia. For decades, its origin was debated, with theories ranging from a comet to an alien spacecraft. The difference with Atlas is that we are witnessing its journey in real time, with the tools to analyze its chemistry, trajectory, and possible intent before it vanishes forever. Explanations begin to fracture. Some scientists insist Atlas is simply a bizarre comet, and the patterns are mere coincidences. Others, more daring, whisper what many are afraid to ask. Is Atlas artificial, or has it been steered into our path? With only one window to get close to Atlas, a window that is closing with every passing day, the stakes for decoding its secrets have never been higher. As the scientific community divides, urgent debates erupt over how to proceed. Every hour lost brings us closer to the moment when Atlas will be gone forever. This is the risk. If we jump to conclusions, either dismissing Atlas as just another comet, or assuming it is a messenger without proof, we blind ourselves to the truth. We could overlook patterns that rewrite our understanding of the galaxy, miss signs of intelligent life, or ignore warnings meant for us alone. Atlas is vanishing behind the sun. The clock is ticking. Do we possess the tools and the sheer fortune to seize this once in an epic chance? Consider the lessons from the history of science. When pulsars were first discovered in 1967, the regular radio signals led a group of astronomers to nickname the source LGM-1 for Little Green Men. Although the phenomenon turned out to be natural, the willingness to entertain radical possibilities helped drive deeper investigation. Today, the same open-minded skepticism is vital as we confront the enigma of Atlas. As 3i Atlas sweeps past its closest point to the sun, Earth's eyes will be blinded by solar fire at the precise instant Atlas exposes its most intimate secrets. No ground-based telescope, no matter how sophisticated, can cut through that glare. Just as Atlas could bear its structure, chemistry, or perhaps its very origins, our window for discovery is slamming shut. Yet hope is not extinguished. Only two machines stand ready, ESA's JUICE, orbiting mighty Jupiter, and NASA's Psyche, threading the icy dark of the asteroid belt. From these rare vantage points, they might catch the fleeting signature of Atlas, glimpsing what no human eye or terrestrial instrument ever could. If mission teams act with daring and speed, these robotic scouts could collect images and data at a clarity never before achieved for an interstellar wanderer. For example, ESA's JUICE mission was designed to study Jupiter's moons, but its instruments are sensitive enough to detect faint, fast-moving objects. The team could repurpose their observational schedule, aiming cameras and spectrometers at Atlas as it passes. NASA's Psyche, meanwhile, is equipped with high-resolution imagers and could attempt a distant flyby, capturing unique data before Atlas disappears into the void. If we let this moment pass, the loss will echo through generations. Atlas is not merely frozen chemistry. It is a time capsule older than Earth, and possibly something stranger, a messenger or even an artifact. Missing our chance could mean surrendering answers to the deepest mysteries, how our solar system was born, or whether we are truly alone in the vast dark. Opportunities like this do not repeat. Some estimates warn it could be centuries, even thousands of years, before another such visitor appears, or worse, never again. A larger pattern is emerging. In less than 10 years, not one, not two, but 3 interstellar objects have crossed into our solar system. Each has carved a path more improbable than the last, defying the odds so wildly that even cautious astronomers now wonder if randomness still holds sway. Are we simply becoming better hunters, or is the galaxy itself changing around us? To draw a parallel, consider the Cambrian explosion in Earth's history. For millions of years, life was simple and unchanging. Then, in a geological blink, a riot of new species appeared. Similarly, the sudden influx of interstellar objects may signal a shift in galactic dynamics, or perhaps a new phase in our ability to detect cosmic visitors. A more unsettling thought hangs in the air. What if these arrivals are not random at all? Could they be travelers with intent? Messengers or probes sent to be found? Some now whisper the ultimate question: are we only detecting those that wish to be seen? Now, as mission planners scramble and the world holds its breath, one truth becomes clear. What happens in the next few days will echo for centuries. The universe is watching, and so are we. This idea recalls the concept of the zoo hypothesis in SETI, the search for extraterrestrial intelligence, which posits that advanced civilizations might be observing humanity from a distance, choosing when and how to make contact. Could Atlas be a deliberate emissary, a test, or even a cosmic invitation? The stakes could not be higher. To falter now is to lose not only scientific treasures, but our standing as explorers, our legacy, and perhaps our very chance to recognize a cosmic greeting or a warning. We may never learn what we missed or how close we came to a discovery capable of rewriting the story of humanity. Atlas demands more than routine curiosity. It demands that we sharpen our skepticism, upgrade our tools, and dare to imagine beyond the boundaries of tradition. Each discovery like this does not merely expand what we know, it redraws the very map of what is possible in science. Atlas, with its improbable trajectory and ancient origins, is a stark reminder that nature does not always obey the rules we think we know. Our methods must remain agile, anticipating the unknown. The cosmos will not slow down for our habits or assumptions. Instruments, missions, and international collaborations must be designed for surprises, because the greatest discoveries often hide in the anomalies, those things that refuse to fit our patterns. To illustrate, consider the Hubble Space Telescope's discovery of dark energy. Astronomers were searching for supernova to measure the universe's expansion rate, but instead they uncovered a force accelerating that expansion, a finding that overturned a century of cosmological theory. Similarly, the study of Atlas could force us to rethink everything from planetary science to the possibility of galactic engineering. Atlas exposes the fragility of our certainty. Its arrival demands that we assemble teams across continents, link telescopes on every continent and in orbit, and share data without hesitation. Only by uniting our efforts can we catch these rare visitors, study them in real time, and adapt quickly as new evidence emerges. But it is not enough to simply react. We must recognize patterns. When 3 interstellar objects appear in just over a decade, each breaking our expectations, we have to ask, are these chance encounters? Signs of a changing galactic neighborhood? Or something more deliberate? Patterns like these might point to deeper forces at play, or even hints of intent on a scale we have never faced. To take practical steps, international agencies could establish a dedicated interstellar visitor task force, pooling data, resources, and expertise to respond rapidly to new discoveries. Public engagement should also be strengthened, inviting citizen scientists to help scan telescope data for anomalies, and encouraging open scientific debate rather than closed-door skepticism. Atlas is a messenger of humility. The universe is older, stranger, and perhaps more communicative than we have ever dared to believe. Each interstellar object is not just a relic from beyond, it is a challenge, urging us to reconsider our place in the cosmos and the limits of what we think we know. Here, skepticism and openness are equally vital. If we dismiss outliers too quickly, revolutionary truths may slip through our fingers. Yet, if we surrender to wild speculation, we risk chasing illusions. Science thrives when it asks the hardest questions and keeps listening for answers that challenge its deepest assumptions. But Atlas is not merely a puzzle for scientists. Its arrival sends ripples through our culture, our politics, and our collective imagination. Atlas is gone, but a larger question lingers. When the next cosmic messenger comes, will we recognize it in time? And will we be ready to act? Now, humanity stands at a turning point. If we learn from Atlas, adapting our technology, our mindset, our vigilance, we might lead the next great leap in discovery. If we hesitate, we risk fading into irrelevance, missing messages written across billions of years, and letting history pass us by. For instance, science fiction authors have long envisioned encounters with interstellar messengers. From Arthur C. Clarke's Rendezvous with Rama to Liu Cixin's The Three-Body Problem, the arrival of an inexplicable object often forces societies to rethink their assumptions, change policies, and unite in pursuit of understanding. Today, real-world events are echoing those fictional scenarios, reminding us that the boundary between imagination and reality is thinner than we might believe. For generations, we scanned the heavens, expecting only silence and randomness. Then came 3I Atlas, shattering those expectations. Its path was impossibly exact, its chemistry unchanged for over 7 billion years, its planetary flybys too deliberate to be dismissed as mere chance. The real danger is not just missing these visitors, but failing to ask better questions. Was Atlas more than a relic, perhaps a message, a probe, or even a test? If so, what have we learned about ourselves and how we respond? Are we prepared to see intention behind the veil of randomness, or will our skepticism blind us to evidence that challenges our categories? As Atlas vanishes into interstellar darkness, humanity stands at a crossroads. Our skepticism, our instruments, our methods, they nearly failed us. Had we ignored the early warnings, the improbable alignments, the ancient chemistry, the uncanny timing, what truths might have slipped past unnoticed? The quiet that followed Oumuamua and Borisov fostered complacency, but Atlas reminded us that the extraordinary can emerge when we least expect it. To overlook such signs is more than a scientific misstep. It is a risk to our future, a missed chance to reshape our story, to discover we are not alone, or to learn from intelligences far older than our sun. Next time, the stakes could be even greater. Knowledge, reputation, perhaps even the safety or destiny of our species may depend on our choices. The question lingers, closing our journey with both hope and uncertainty. When the next ancient traveler cuts across our sky, will we see it for what it truly is? And if a message waits within, will humanity finally be ready to listen and to answer? Now, as the final traces of Atlas fade from our telescopes, the true test begins. Have we learned enough to perceive the next messenger? Will we act with humility, curiosity, and resolve? Or will we let history repeat, missing the most profound opportunities of our age? To prepare for the next encounter, institutions could invest in rapid response probe missions, small, agile spacecraft ready to launch at short notice to intercept interstellar objects. Space agencies could also develop AI-powered observational systems capable of identifying unusual trajectories in real time and alerting international networks instantly. These practical steps would ensure that the world is not caught off guard again.